dear students. You are now ready for Module 17, which is about probability of independent and dependent events. After watching this video, you are expected to solve problems involving probability of independent and dependent events. Let's have a quiz first for you to have an idea of what independent and dependent events is all about. Solve each of the following problems and write the letter of the correct answer. For number 1, for number 2, for number 3, for number 4, and for number 5. Take note that you can always pause and play this video whenever you need time to answer the problem first. Now let's check if your answer is correct. For numbers 1, 2, and 3, numbers 4 and 5. Did you get a perfect score? If not, it's okay, but you have to listen to the discussion of the probability of independent and dependent events. Let's have a recap first. A recall on what you have learned last time by answering this problem. What is the probability of drawing an ace or a king from a standard deck of cards? When drawing an ace and drawing a king happens at the same time, what formula should we use? The answer for number 1 is 2/13. For number 2, it's a no. And for number 3, this is the formula. I hope you made a perfect score. If not, review your VL number 15. To continue with our lesson, I would like you to answer this first. State whether the results of the first event affects the result of the second event. Number 1, is studying hard affects getting a high grade? How about eating a lot? Gaining weight? How about playing computer games? Does it affect submitting all the assignments and projects on time? How about tossing a coin? Does it affect rolling a die? Attending a singing lesson affects the rain? Let's check if your answer is correct. Examples 1, 2, and 3. The first event affects the result of the second event. While numbers 4 and 5, the first event doesn't affect the second event. 1, 2, and 3 are examples of dependent events, while numbers 4 and 5 are examples of independent events. And what does it mean? When a first event affects the probability of a second event, the events are said to be dependent. While when the first event does not affect the probability of the second, the events are independent. I hope the two terms are clear. Now let us have the following examples. Tell whether the events are independent or dependent. Explain. For letter A, letter B, and letter C. Let's have letter A first. You flip heads on one coin and tails on another coin. When you flip one coin, does it affect the other coin? Of course not. Therefore, it's independent because the first coin has nothing to do with the second coin. How about letter B? Your teacher chooses one student to lead a group and then chooses another student to lead another group. Does the first choice affect the second choice? Yes. That's why it's dependent. How does it affect? If you have 45 students in a class, at first you have 45 choices. But on the second choice, you only have 44. That's why your first choice affects your second choice. And therefore, it's dependent. Same with example for letter C. Selecting 3 cards one at a time from a standard poker deck. The first choice of card affects the second choice and the third choice. Therefore, it's dependent. Let's have more examples. There are 2 red balls, 4 yellow balls, and 1 blue ball in a box. 2 balls are drawn randomly one by one with replacement. Find the probabilities of the following events happening. For letter A, letter B, letter C, letter D, and letter E. Let's start with A. 2 yellow balls are drawn. What does it mean? So it means that at first you get yellow, and on the second you get another yellow. That is probability of yellow and then yellow. So what is the formula to solve for the probability of yellow and yellow? All you need to do is to multiply their probabilities. So the word "and" means you're going to multiply the probability of both events. So since there are 4 yellow balls, the probability of getting yellow is 4 over 7. Times 4 over 7, you'll get 16 over 49. So the probability that the 2 yellow balls are drawn is equal to 16 over 49. Let's proceed to letter B. This time, the 2 balls drawn are not yellow. What does it mean? It means you get a non-yellow ball at first, and then on the second attempt, you'll get another non-yellow ball. So therefore, it's the probability of getting a not yellow and another not yellow, which is equal to probability of not yellow times the probability of not yellow. But how many non-yellow balls are there? There are 2 red balls and 1 blue ball, which is equal to 3 over 7 times 3 over 7 will have 9 over 49. So the probability that the 2 balls drawn are not yellow is equal to 9 over 49. How about the letter C? Only 1 yellow ball is drawn. What does it mean? Since we're going to draw the ball one by one, it could mean 2 things. Yellow first, followed by a non-yellow ball, or non-yellow ball first, followed by a yellow ball. So that will be equal to the probability of yellow and not yellow plus the probability of not yellow and yellow. You hear the word "or," that's why we have addition. Therefore, we'll have the probability of yellow is 4 over 7 multiplied by the probability of not yellow, which is 3 over 7, plus 3 over 7 times 4 over 7, which is equal to 12 over 49 plus 12 over 49 is equal to 24 over 49. So the probability that only 1 yellow ball is drawn is 24 over 49. Hope it's clear. Let's proceed to letter D. At least 1 ball drawn is not yellow. The word "at least" means you can have 1 non-yellow ball or 2 non-yellow balls. But aside from getting 1 yellow ball, non-yellow ball, the first one is a non-yellow, or the first one is a yellow ball. Therefore, we'll use this formula. The probability of yellow, non-yellow first, or the probability of non-yellow followed by yellow, or the probability that both are yellow. So it's equal to 4 over 7 times 3 over 7 plus 3 over 7 times 4 over 7 plus 4 over 7 times 4 over 7, which when simplified is equal to 12 over 49 plus 12 over 49 plus 16 over 49, which is equal to 40 over 49. So the probability that at least 1 ball drawn is not yellow is equal to 40 over 49. Whew, it's a long one. Let's have another solution. I think this is much easier. That is, if we're going to use what we call complement, because we have here the word "not." So let's use the complement. The complement of not getting a yellow ball is if we get both non-yellow, at least. Therefore, we'll make use of the formula 1 minus the probability of not yellow and not yellow, which is equal to 1 minus 3 over 7 times 3 over 7, which is equal to 1 minus 9 over 49, which is equal to 40 over 49. Definitely, we'll arrive with the same answer. This is a shorter one. Don't you think? Let's proceed to letter E. The two balls thrown are of the same color. If we have the same color, what are our choices? We can have 2 red balls or 2 yellow balls. We cannot make use of blue because there is only 1 blue ball. Therefore, we have the probability of yellow and yellow or the probability of red and red, which is equal to 4 over 7 times 4 over 7 plus 2 over 7 times 2 over 7, which is equal to 16 over 49 plus 4 over 49, which is equal to 20 over 49. So the probability that the two balls thrown are of the same color is equal to 20 over 49. I hope I made it clear. How about number 3? 3 cards are chosen at random from a deck of 52 cards without replacement. What is the probability of choosing a king, a queen, and an ace in order? In order means we're going to do it one at a time. Without replacement, meaning it's dependent. So how are we going to solve for it? So we have to find the probability of getting king, and then queen, and then followed by ace. And that is probability of king times probability of queen after king, because the first choice affects the second choice, times the probability of ace after queen, because the first and second choices affects the third choice. A substitution, 4 over 52, because there are 4 kings out of 52. There are 4 queens, but we only have 51 cards in all because the first one was taken. And then 4, because we have 4 aces, so this time we only have 50 cards because the first 2 cards are chosen, which is equal to 4 raised to 3. In symbols, probability of A and B is equal to probability of A times probability of B. When the outcome of one event affects the outcome of another event, they are dependent events. If 2 events, A and B, are dependent, then the probability of both events occurring is the product of the probability of A and the probability of B after A occurs. In symbols, probability of A and B is equal to probability of A times probability of B after A. For our valuing, I want you to, in your journal, reflect on the following. It's time for your post test. I want you to identify what is being asked in each question and write only the letter of the correct answer. Number 1, 2, 3, 4, 5. I'm hoping that you get a perfect score. Let's check. Numbers 1, 2, and 3. Number 4 and 5. Good job if you did. You are now ready